The ambiguous case. Okay, so we talked about it in class. This happens when you're given information when you were going around the triangle. If the information given is angle, side, side, then the ambiguous case could happen. So suppose we have angle A, you're given as 30 degrees, and side length of the AB is 10 centimeters, and then BC, for instance, could be 7. Then going around, starting from the angle, side, side. Okay, so I know the ambiguous case could happen because there is no restriction on the side length AC. That means I could have BC over here, right? Where this is 7 as well. Okay, so what happens then? Well, we know this length here is the same as this one. So if you look at the triangle in red, this triangle here, okay, if this is C, this is also C, right? Then that's an isosceles triangle, and whatever this angle is, over here is going to be 180 minus that. Okay, that's called this C. Let's call it C prime. So you get two triangles. One of them is going to be on the outside, as you see here, ABC. The second one is over here, ABC prime. So that happens when you're given information in this way, angle, side, side. So this third side can go out here, making C an acute triangle, or you could have an obtuse triangle for C. But not always. Just because you're given angle, side, side doesn't mean you're always going to get two cases. Here are two examples where that might not happen. Number one, well, the third side given could be exactly this long, making a right triangle. So in this case, if this is 5, when that's 10, then you're going to get a right triangle, and there's no ambiguity. That's going to be one right triangle, and that's it. Another case is if this length BC that's given to you is longer than the first side, then the only way that this could swing in and meet here is if this third side length is shorter than 10. If this is, for instance, 11, if this length is 11, then if you try to swing this by in here, that it's not going to go in here. It's got to go that way because that's longer than 11, and that's no longer going to be the same triangle. So you can only make one on the outside. Okay, but in general, if you get a triangle and when you label all the triangles, you get angle, side, side, then you can suspect that you might get two cases. And sometimes the question will tell you that you get two cases, and if you're told that, then you know that one of the triangles is going to be this acute one, and the other angle C is going to be 180 minus this one. So let's look at an example. Construct two possible triangles. They're telling you there are two cases when angle A is 30, so there's 30 degrees, and BC is 6 centimeters, and AB is 10. Okay, so let's look at that. So 6 is definitely smaller than 10, so you could get the second case where the 6 goes in this way. Let's call this C prime. Then I'm going to draw two triangles. Okay, so case 1, the originally drawn triangle with the acute C, where you have 30 degrees here, and it's 6, and then 10. So I'm going to use sine rule. Sine of 30 over 6 is equal to sine of C equal over 10. And if you solve for C, you get arcsine of 10 times sine of 30 over 6. And let's find out what that is. Let me make sure I'm in degree mode. Okay, so arcsine of 10 times sine of 30 over 6. It's going to be 56.4. So that's 56.4 degrees. And that'll make angle B, the measure of angle B is going to be 180 minus 56.4 minus 30. What is that? 180 minus 56.4 minus 30. That's going to be 93.6. So I found all three angles, or the missing two angles in case 1. In case 2, I am looking at this over here. Okay, that's my case 2. In that case, the angle C prime, or of course angle A is still 30, but angle C prime, it's 180 minus angle C. So 180 minus 56.4, which would be 123.6 degrees. Okay, then angle B prime, right? Let's call this angle B prime, and that angle would be 180 minus 123.6 minus 30, and that would be 180 minus 1.6, 26.4 degrees. There. So those are the two angles in two cases. Here's another example. Now let's look at the triangle. So let's draw this, and here's A and B. Angle A is 30 degrees, and AB is 10 centimeters, and BC is 12. What you notice here is that BC is bigger than or longer than AB. So you cannot get an ambiguous case because this 12 centimeter leg is not going to swing in and meet somewhere here, right? So that's not going to happen. So there's only one case. And so let's find the length. Sine of 30 over 12 is equal to sine of C over 10, and I won't skip my steps, so multiply both sides by 10. 10 times sine of 30 over 12 is equal to sine of C, and then you want to solve for C, so C is equal to arcsine of this 10 sine of 30 over 12. And what is that? Arcsine of 10 sine of 30 degrees over 12. That is 24.6 degrees. Okay, up to 3 sig fig. And then angle B, then, this is 24.6 degrees. That third angle is got to be whatever makes it add up to 180, right? So 180 minus 30 minus 24.6, 180 minus 4.6, it's going to be 125.4. So angle B is 125.4 degrees. So we found missing angles.